I am Arvinderjit Singh Mehmi, lecturer, Production Engineering Department from Government Polytechnic College, Amritsar. My subject is tool engineering and the topic given to me today is jigs and fixture design. So, first of all, let us discuss what is meant by jigs and fixture. Simply speaking, jigs and fixture are a special purpose tool which are used to facilitate production. When workpieces are to be produced on a mass scale, the mass production of workpieces is based on the concept of interchangeability, according to which every part will be produced within an established tolerances. Jigs and fixture provide a means of manufacturing interchangeable parts since they establish a relation with predetermined tolerances between the work and the cutting tool. They eliminate the necessity of special setup for each individual part. Once a jig or fixture is properly set up, any number of parts may be readily produced without additional setup. Now, where the jigs and fixtures are used? These are used to reduce the cost of production, as their use eliminates the laying out of work and setting up of tools. To increase the production, thirdly, to assure high accuracy of parts, then to provide for interchangeability, to enable heavy and complex shaped parts to be machined by being held rigidly to a machine, then for reduced quality control expenses, then it is these are used to for increased versatility of the machine. The seventh point is with the use of jigs and fixture, same machine can be used for more than one operations. That's why it is called, these jigs and fixtures are used for increased versatility of the machine tool. Then these are used for skilled labor. These jigs and fixtures are used for saving labor. Their use partially automates the machine tools. Now, in brief, how we can define a jig in a very simple way. A jig may be defined as a device which holds and positions the work, locates or guides the cutting tool relative to the workpiece, and usually is not fixed to the machine table. It is usually lighter in construction. And similarly, a fixture is a work holding device which only holds and position the work, what does not in itself guide, locate or position the cutting tool. This setting of tool is done by machine adjustment and a setting block or by using slip gauges. A fixture is bolted or clamped to the machine table. It is usually heavy in construction. Jigs are used on drilling, reaming, tapping and counter boring operations, while fixtures are used in connection with turning, milling, grinding, shaping, planing and boring operation. So, let me repeat. Jig is a device which is used to hold and position the workpiece, At the same time, it locates and guide the tool with respect to the workpiece itself. Because jigs, it is lighter in construction, it is simply, it is not attached or fixed to the table of the machine, and fixture, it is a work holding device which holds and position the work, but it does not guide or guide the tool with respect to the workpiece. And these fixtures are heavy in construction, so that is why these fixtures are bolted to the machine table. Then, to fulfill their basic functions, both jigs and fixture should possess the following components or elements. It must have a sufficiently rigid body, plate, box or frame structure into which workpieces are loaded. It must have some locating elements. Thirdly, it must have some clamping elements. It must have some tool guiding elements for jig or tool setting elements for fixture. It must have elements for positioning or fastening the jig or fixture on the machine on which it is used. Now, suppose 4 holes are to be drilled in a rectangular plate. Now, I show you a plate in which 4 holes are to be drilled. Now, what operation you require to get 4 holes drilled in a plate are as follow. First of all, spread the solution of chalk on one side of the plate, then let it dry. Mark the centers of the hole by the pointer. Hold the plate of the machine and then drill the holes. A great care is required while drilling operation is being done. The holes must be exactly in the correct position where the centers are marked, and the centers must be marked in the correct position. Thus, we see that it requires a great care and more time, which cannot be given in the manufacturing companies, where time is money and labor is poor. If 2000 plates are to be drilled, a lot of time will be required, and also a number of workers will be required to perform all these operations before drilling. What drilling may be done quite easily with less care and labor within a less time by means of jigs and fixture. Now, you can see on the monitor this is the workpiece where we want 4 holes to be drilled. Then we have a plate. At the top, it is a, section view is shown. 4 holes are drilled on a plate, and drill bushes are inserted in these holes. The inner diameter of the bushes is slightly more than the holes required to be drilled in the plate. Then, number of plates are placed below this standard plate, or this standard plate is called a drilling jig, and these plates are clamped and holes are drilled through these drill bushes. Figure shows a drilling jig. 4 holes are drilled very accurately in a plate of the job size. Bushes are inserted in the holes and spot welded. The inner diameter of the bush is slightly larger than the hole to be drilled to take the drill inside it. This device is called a drilling jig. It is kept over a number of plates and clamped with them by means of another device which is called a drilling fixture, which is not shown in the figure. The holes are located in the jig accurately with which guide the drill. Thus, we do not require to mark the center of the hole on each plate and to drill them one by one. Simply put the drilling jig on a number of plates, clamp them and insert the drill through the bushes of the jig. Holes can be drilled in 2000 plates quite easily and within a less time. Hence, jigs and fixtures facilitate the operation and increase the production. Jigs and fixtures are usually designed in tooling department by the tool engineer. The jigs and fixtures are named according to the operation as drilling jig, drilling fixture, welding jig, welding fixture, forging jig, forging fixture, facing jig, facing fixture, etc. Then factors of designing the jigs and fixture. What factors must be kept in mind while designing the jigs and fixtures? First point to be kept in mind, that is clamping. Clamping system of jig and fixture with component should be easy and simple. It depends upon the shape of jigs and fixture. The clamps should be placed immediately above the sporting points to avoid distortion and should be operated from the front of the machine to avoid obstruction. So, clamping should be so designed that these clamps should be placed on the sporting points to avoid distortion of the workpiece. And then clearance. The jig or fixture must have sufficient clearance for operating the tool and removing the chips. Blind spots and corners for chip accumulation should be avoided. Generally, the chips are carried out by the coolant to clear the work and the jig or fixture. Then design. Jigs and fixtures are so designed that they may be able to withstand usage without losing accuracy. Means jigs and fixtures should be so designed that they can withstand the ill uses of the jigs and fixtures. Swinging parts should be properly balanced. Most economical design of jig and fixture will be liable to take every machining operation. Previous experience of designing the jig and fixture is of considerable importance. A great attention should be given to store and lift the jigs and fixture. Next point is handling. If the jigs or fixture is of small size, then attention must be given to its weight. Heavy jigs and fixtures should have eye bolts or lifting lugs for the lifting purposes. So, if the jigs and fixtures are very small or small in size, then must care be taken about their weights. And for heavy jigs and fixture, to carry them from one place to another, some eye bolts or lifting lug must be provided on the jigs or fixtures. Then comes loading and unloading. Sufficient clearance will facilitate the jigs to handle easily. Short bearing surface should be arranged when locating on a diameter, a great care should be taken in loading and unloading the jigs and fixtures. Then comes foolproofing. The design of jig and fixture should be so arranged that the job cannot be placed incorrectly in it. This foolproofing is meant, and we can say that design of jig and fixture should be such that incorrect job or job should not be placed incorrectly in it. This system is called foolproofing, and the incorporation of foolproofing peg will assist here. Then gauge and setting blocks, there should be some provision on each jig or fixture for setting blocks and gauges when they can be usefully employed. Then locating pads, wide bearing surface should be avoided to keep the jig and fixture free from swath and dirt. Only a few points by which the equipment is located will permit easy cleaning. 3 pin points are sufficient to locate the rough casting and forged faces. Long jigs and fixture are supported by minimum points. Then datum, only a datum should be used to reduce the effect of accumulative errors, and it should be used throughout the whole process of the manufacture. The best chosen datum will provide sufficient material for each operation in the production cycle. If more datum are to be chosen, care should be taken to reduce errors. Then machines. In designing the long jigs and fixture, the machines by which they are to be operated should be studied and noted their possibilities and limitations. The size of the equipment should be such that it can be accommodated easily on the machine. So, in this point, while designing the jigs and fixture, we must know the machine capabilities and its limitations, because these jigs and fixture are to be used on the machine table. So, first of all, we must know the machine capabilities and limitations. Then material. The material required for the jigs and fixture should be suitable and cheap. In essential parts, the special alloy may be used. Welded structure should be avoided where vibration is created during the operation. Good heavy cast iron base should be provided. In such a case, heat treated parts should be clearly noted. Then safety. Every care should be taken in designing the jigs and fixtures to avoid the dangerous points. Sharp corners should be rounded off. Holding points should be best located. Then economic condition. Attention must be given to the economic condition when designing the jigs and fixture. Cheap and simple design is profitable. Some jigs and fixture are so designed by which a number of jobs are operated at a time. Single or multiple tools used, manual, semi-automatic or full automatic operations done extra are considerable factors in economical conditions. In brief, following principles are considerable in designing the jigs and fixture. So, important points which are to be considered in designing jigs and fixture, they are: number 1, accurate location of production, clamping the production, selection of bushes of correct style and size, easy and quick removal of production, economic condition. Then comes types of jigs. We take drilling jigs and the types of drilling jigs. As there is no hard and fast criteria for classifying the drilling jigs, however, drilling jigs may be classified as follow. First of its type is template jig. This is the simplest type of drilling jig. It is simply a plate to shape to the shape and size of the workpiece with the required number of holes made in it accurately. A simple template type of jig is shown in the figure. It is placed on the workpiece and the holes in the workpiece will be made by the drill, which will be guided through the holes in the template. The plate should be hardened to avoid its frequent replacement. Now, you can see on the monitor at the top we have sectioned view of the drilling jig clamped with the workpiece. The upper portion is our template jig and the lower is our workpiece. These holes are drilled through these holes with the help of a drill. So, this type of template jig is used where only a few number of plates are to be produced, because this cannot be used for a number of jobs because of its wear and tear. This type of jig is suitable if only a few parts are to be made. Then second type is plate type jig. This is an improvement over the template type of jig. In place of simple holes, drill bushes are provided in the plate to guide the drill. The workpiece can be clamped to the plate and the holes drilled. Now, you can see on the monitor we have plate type jig. This plate type jig is very similar to the template type jig. The only difference is in the plate type jig we have drill bushes in the holes. These bushes guide the tool to drill the holes in the workpiece. The lowermost plate is our workpiece. Then open type jig. In this jig, the top of the jig is open. The workpiece is placed on the top. Now, you can see on the monitor a figure is shown of open type jig, which is open at the top. We have some drilling plate which is clamped with the help of the clamps. These clamps are used to hold the job, and hole is drilled through this drilling bush. Then comes swinging leaf type jig. It is also a sort of open type jig in which top plate is arranged to swing about a fulcrum point so that it completely clears the jig for easy loading and unloading of the workpiece. The drill bushes are fitted into the plate, which is also known as leaf, latch or lid. Now, you can see on the monitor it is a swinging leaf jig. This plate can swing this way this is clamp which is used to hold the job, and two holes are drilled through these drill bushes. Then comes box type jig. When holes are to be drilled in more than one plane of a workpiece, the jig has to be provided with equivalent number of bush plates. For positioning the jig on the machine table, feet have to be provided opposite each drilling bush plate. One side of the jig will be provided with the swinging leaf for loading and unloading of the workpiece. Such a jig would take the form of box. The body of such a jig should be as light as possible, since it will have to be lifted again and again. Now, you can see on the monitor box type jig. This type of jig is used when holes are to be drilled in more than one plane. That is the first plane where we require a hole, and the second plane where we require two holes. So, in this case where holes are required in more than one plane, we use this box type jig, and we have two jig plates, one is this and second is this. Bushes are inserted in this drill plates, and this is clamp to hold the job. This hole is drilled through this drill bush, and these two holes are drilled through these two drill bushes. Then channel type jig. In this type, the jig is made of standard steel channel section. This jig can also be provided with the swinging leaf to form a channel and leaf jig. Channel type jig is shown on the monitor. This is made of standard steel channel. Similarly, the jig plate is made to swing like this. This is clamp to hold the job. Two holes are drilled through these drill bushes. Then fundamentals of jigs and fixture design. For designing jig or fixture, the following data should be available to the designer before designing the jig and fixture. First of all, working drawing of the finished part, the specifications for its inspection, and the working drawing of the blank. The term blank here refers to the starting rough piece which will be machined to get the finished part. The blank may be in the form of a casting, a stamping, a forging, a blank cut from the rolled stock, or a blank produced by powder metallurgy. Then operational sketch of the part for the proceeding and given operation. If jig or fixture is being designed for some intermediate operation, so we must have some operational sketch available to the designer. Then a process planning sheet for the given part, which indicate that sequence and a description of operations to be performed on the blank. So, a process planning sheet should be available to the designer, so that he can know what operation can be done after what operation. Then standards for the components and units of machine tools, jigs and fixture, as well as manual of standard design of jigs and fixture.